One of the earliest attempts for hypersonic flight was made in Germany before World War II. Eugen Sanger and Irene Brett in the late 1930s started a program called the Silver Bird. It was a rocket-powered suborbital bomber. It is considered an early hypersonic concept, though it was never built and existed only as a design. Unlike ballistic missiles, which travel in a high arc and fall to target, Silverbird was to generate lift during re-entry, allowing controlled flight within the atmosphere at hypersonic speeds, which is a defining trait of modern hypersonic weapons. The Silverbird program had a profound intellectual influence on post-World War II American aerospace and hypersonic research, even though it was never built. America's own program to achieve hypersonic speed started with the X-15 rocket plane. It was a rocket-powered research aircraft operated jointly by the United States Air Force and NASA under the X-plane experimental program. During the 1960s, it shattered records for speed and altitude, reaching the very edge of space and returning with crucial data that shaped the future of both aircraft and spacecraft design. On 3 October 1967, pilot William J. Knight achieved the program's fastest flight, reaching Mach 6.7. This remains the highest speed ever recorded by a crewed, powered aircraft, a record that still stands today. After X-15 came the Boeing X-20 Dinosaur, or Dynamic Soarer. It was a project aimed at performing military missions, as well as satellite maintenance and space interception. However, it was canceled shortly after construction began. Then came the Rockwell X-30 in 1986. It led to significant advancements in materials and aerospace design. This led to the development of Project X-43, which was part of the X-plane series, and NASA's HyperX program. It set multiple airspeed records for jet aircraft. It is a very important project, as it is one of the first scramjet technology development program in the world. Unlike traditional jet engines, this design eliminates the need for complex mechanical components, offering a simpler, more efficient solution for extremely high-speed travel. Its first successful flight took place in 2001, where it reached a speed of Mach 7, and in 2004, the X-43 achieved a world record-breaking Mach 9.6.
Mach 9.8 or 7,000 miles per hour. NASA's supersonic combustion scramjet screamed into aviation history on November 16, 2004.
It demonstrated the viability of scramjet engines at hypersonic speeds. The X-43 remains the fastest jet-powered aircraft on record till date. Around 2010 came the Hypersonic Technology Vehicle 2 from DARPA. It was an experimental hypersonic glide vehicle developed under the DARPA Falcon project. The aim was to achieve speeds around Mach 20. It was designed to demonstrate technologies for a conventional prompt strike capability. It would enable the United States to reach any target globally within an hour. At Mach 20, the flight time between New York and Los Angeles would be under 12 minutes. The vehicle reached Mach 20 but lasted only for 9 minutes. It was stopped after 2 tests as valuable data on aerodynamics, flight performance, and high-temperature effects were gathered from the first 2 flights. Then came the X-51 Wave Rider program, which was an experimental hypersonic aircraft jointly developed by the U.S. Air Force, DARPA, NASA, Boeing, and Pratt & Whitney. It was designed to test scramjet propulsion and aimed to demonstrate sustained hypersonic flight. First launched in 2010, its most successful flight occurred in 2013, where it flew at Mach 5.1 for over 3 minutes before splashing down. The X-51 marked a key step toward the development of future high-speed missiles and aircraft. As evident from its development history, the United States has historically prioritized hypersonic aircraft over hypersonic weapons. At the time, the U.S. already possessed highly capable ballistic missiles, thus reducing the perceived need for hypersonic weapon systems for deterrence. The U.S.'s obsession with hypersonic crewed aircraft can be seen even in movies like Top Gun: Maverick. However, this began to shift in the 2010s when rival nations, particularly Russia and China, demonstrated significant progress in operational hypersonic weaponry, such as Russia's Avangard and China's Dongfeng ZF. These developments challenged U.S. missile defense capabilities and strategic deterrence. In response, the U.S. redirected its efforts towards hypersonic weapons programs to close the emerging gap and maintain technological parity. Currently, there are several ongoing hypersonic weapons programs in the U.S. For example, the Long-Range Hypersonic Weapon, or Dark Eagle, a ground-launched glide vehicle developed for the U.S. Army. It boasts a range of over 2,775 kilometers and is nearing operational deployment. There is also the Hypersonic Attack Cruise Missile, developed jointly with Australia. The OpFires program by DARPA is another notable project, focused on launching hypersonic weapons from mobile ground platforms for tactical missions. Then there is the HALO program, which is the U.S. Navy's effort to develop hypersonic strike capabilities from carrier-based aircraft. Even though the U.S. is late to the game, today, multiple branches of the military is pursuing different hypersonic platforms to meet the evolving demands of modern warfare. However, as of 2025, the United States has not yet inducted any hypersonic weapons into active military service.